there are certain things you have to know about the geosphere, and the first thing is you have to know the composition of the geosphere. So you have core, mantle, crust. And the next time I have PowerPoints, I will go into you after, obviously. So at least there's some kind of dedication here. All right, so the core. You need say C for core, C for center, so you remember. You have to know that it's partly solid and liquid. So there's like a mixture going on there. What is this liquid?
Iron.
Iron. Good. Write that down. Sometimes actual content of the parts of the geosphere appear on the AP exam. C for core, C for center, high temperatures, mainly liquid and pretty much 50-50. Then you've got the mantle. M for mantle, M for what? Middle. M for magma. Think of those three things. Middle, magma, mantle. And then you have the crust, which is mainly what we're going to focus on. Yeah.
Is this on canvas?
It is. You have this already.
I do.
Yep. The crust, think of obviously the outer layer, like your pizza crust, right? The outer layer of the pizza. And it's thin and it's composed of plates. What do we call these plates? Tectonic plates.
It's this one, right?
Correct. I just went, I'll pause.
Mine doesn't have the little house.
What happened to my,
Yeah.
and the lithosphere. Remember we talked about atmo, hydro, litho being the three major layers of Earth for years that I taught environmental science, and then they regrouped it and called it geo. Well, the lithosphere makes up the upper mantle and crust. So you could put a little star and put your litho. Lithosphere makes up upper mantle and crust. So if they do reference, the lithosphere is part of the geosphere, and it only, so what part is not lithosphere of the geosphere? Core, okay, and
lower
mantle, there.
You're part of the mantle or the...
Upper mantle and crust. And there's a picture of, kind of like, look at that picture, because your lab, you're gonna have to re-reference that picture. You see the core, and you're gonna have this picture obviously in your notes. You see the mantle. Asthenosphere is that layer that borders, let's say, the mantle, and then lithosphere would include part of the mantle and the crust.
Is the geosphere part of the lithosphere?
No. Well, yeah. It's within both. Used to be one term. All right, so if we look at the lithosphere, what do you think is the largest part of the lithosphere? Upper mantle and crust. So what would make up the biggest part of the lithosphere? You're not getting it. Go back to what Earth is and what are my layers and what part? It's definitely going to be rocks. Where? Okay, I'm going to re-reference the question. What do you think makes up the majority of our crust? Look at the picture. Yes. If 70% of Earth is oceans, then 71% of our crust is oceanic crust. That makes sense? And then we've got the continental crust, which makes up another, let's say, 30%, right? If we're doing averages. And those numbers, so our tectonic plates, these come up on the AP exam. They reference the way they move, and they reference what those movements lead to. Okay, so let's go over the movement. We know they're found in the crust. Think of them as plates, that like plates hold your food, plates hold Earth in place, and when those plates move, things happen, right? A lot of things happen. So let's go over that. Here's a picture. This is going to be on the AP exam too. There's going to be maps. There's always a map question, and I shouldn't say that. Ring of fire will come up twice, plates, and then when we talk about alternative energy, it's another key component. So just knowing that border, you'll never have to know which type of boundary lands on which, no. But you will have to know the next part, which is, how I ended up there, I have no idea. And I zoomed in. Magma Rising. And it kind of helps you understand why the plates move, okay? So you have magma will rise, and then it'll spread, rising from where? From the mantle, okay? It'll spread across, and when heat spreads, what happens? It cools. And when hot liquid rock cools, it does what? Solidifies. So then it hardens, and then it starts applying. You still got the heat always coming up from below, applying pressure, and then it cracks, okay? So that's why plates shift. And there's 3 ways they shift. These usually, I never have a problem with you getting these wrong. Transform faults, they move in opposite directions. You need to draw your arrows. Well, obviously you have the notes, but the words and the arrows. And then we'll talk a little bit more about what they lead to. What do you think this is? Coming together? Convergent, okay? C for coming together. Oh, and I put there, transform faults and subduction zones are convergent, are linked to convergent movement, okay? And then you've got away, divergent, and that is what leads to oceanic ridges. Now I'm going to give you a little tip for the test. Question, ask me.
What does it say, like,
Transform faults, convergent, process called subduction, and then divergent creates oceanic ridges.
Wait, what does it say on the transform?
Faults. Question?
A ridge?
Lead to, okay? So who could tell me what Pangaea is?
Like the original, like how the layout of the Earth was.
The original layout of the Earth, okay? One big supercontinent. I've seen that actual definition come up. So if you want to write that, one big supercontinent. And then I have a picture of how scientists believe this happened. And there's 225 million years ago, then 200 million years ago, and you don't have to know this. You don't have to know errors and none of that. But just so you could get an idea, present day. Do you think in like maybe 15 or 20 years I'm going to be adding another map?
No.
Who says no? Who says yes? Okay, so how about 100 years?
No.
So you think this stopped?
No.
No, it's
Okay, it's going to take longer. Good. That's a good answer. It is going to take longer, but the map will adjust. And it could be faster. You just don't know. Because the plates are constantly shifting. And plate shifting leads to land formation. Write that down in your notes. It doesn't just lead to problems. It formed land. We know this from the introduction of the birth of Earth. Well, what happened first?
cooling of the lava or the hot stuff.
You had this boiling soup of Earth, of hotness, that cooled, and then it formed a crust. But that heat underneath kept forming. And then eventually, once we had our atmosphere and our oceans, we still saw land formations because the shifting of the plates. So we know shifting of the plates form lands, they cause volcanoes. What else do they cause? Earthquakes. Tsunamis. Oh, and then I'm referencing magma, metal, mantle. When it pours out of Earth, it becomes lava. Yes. Liquid rock. This little, right? They cause earthquakes, as we mentioned, and those are some major earthquakes of the world, and this is old. So, yeah. Now, I thought I had in my notes. Notice the fault line, okay? And when the floor suddenly rises or drops, you have this upward wave. And that was the end of the notes. Yeah, I can't go back.